This is the brief on electrostatic field forces between point charges. So you probably know Coulomb's law for figuring out the force between charges, right? That's the big picture, global view. But what this material shows us is that the electromagnetic field itself is, well, it's not just sitting there. It's actively managing those forces on a local level. And that's a huge conceptual shift. First up, we're shifting our thinking. It's not just a force between two charges anymore. No, it's the local force the field is putting on a charge. Think of it like this. A charge pushes on the field, and for everything to stay put, the field has to push back with an equal and opposite force. It's all about a local balance. Okay, so how does the field know what to do? How does it know whether to push or pull? Well, that's our second point. It all comes down to geometry. For charges that attract, the field lines pass through the middle plane at a right angle, creating what's called Maxwell pressure. It's like a cushion pushing the field regions apart. But for charges that repel, the field lines run parallel, creating Maxwell tension. Think of a rubber band pulling everything together. And finally, the math actually backs this all up. When you run the numbers using something called the Maxwell stress tensor, you find that the total force the field exerts on that boundary surface, well, it perfectly matches the force you'd expect from Coulomb's law. It's a perfect mathematical confirmation that this local model really works. So the bottom line is this. The field itself is what's mediating the interaction between charges, and it does it using these geometrically defined surface forces to keep everything in perfect balance.